Hey guys, we on first trigonometry and this is new topic because before we explored just trigonometry basics like ratios, applied trigonometry to solving problems. However, this is the first one and that was done by urgent request for several students that actually struggling with this topic. And this is trigonometry with compound shapes where actually you need to apply different sine cosine rule and also sine cosine theorems in order to solve to find some unknowns in your given problem. Okay, so grab your notes, grab your pens, and let's get started. That's the problem one. We're going to consider two problems here. So the first is about application of trigonometry in this shape. Okay, have read and let's start discussing. Here's the owner of the private property and he would like to have a swimming pool. So this blue parts, blue lines indicate that swimming pool. And the shape on the figure shown on the figure. Okay guys, because you have two parallel segments indicate with those two small arrows. So that means you have trapezium. So two opposite sides are parallel. So that's why we have trapezium. We determine the shape. So we need to determine the angle the left hand side makes with the bottom of the pool. So right, this angle marked as x. Okay, so what we're given? We're given the depths 3.5 meter. We're given the bottom lines and the top lines, basically their lanes if you swim from one end of the swimming pool to another one, so 25 meters. Okay, so what we're gonna do, because we need to find angle x and we're given only one angle 80 degrees and no other angles, there is no way to do that using just angles. So we need to have a look at trigonometric ratios, so probably it will give us an idea. What I'm gonna do, I'm going to set up, first of all, that's vertical height that will arrange 90 degrees angle. So right there, so that this small triangle is going to be a right angle. Let's assume this is the height in trapezium. And if we know the height, we understand that angle x will consist of the small part, which is y, and the rest part is going to be 90 degrees. So I mark like this. So 90 degrees angle. Okay, so you understand it's 90 degrees. So that's why in total, angle x will represent the sum of y and 90 degrees. So here is y, our target angle, and I'll mark as this one, pink. No, it's not good color. All right, so anyway, this y is actually target angle. So how to find y? What we need to know. So ideally, we need to know this part, and I mark it as, let's say, this part. Okay. If we know that part, we can calculate using trig ratio. So let's set up letter B for that. And how to find y from here? We can say that tangent of y is going to be b to h. So our target sides are b and h. So first of all, we need to find h. H is actually 3.5 is the depth, so that's why it's already found. So h is 3.5 meters because this is the depth. So next part, ideally we need to find b by subtracting from 25 because this is the whole top side. We need to subtract 20 and we need to also subtract a little part here. So again, if we put the vertical segment, that's going to be a height. So that's also h. We know this. This is 3.5. We know this angle is 80 degrees. So we are going to find this small part and I mark with this small arrow. Okay. And let it be A. So right now, we're going to use that triangle to find A. Because we know 3.5, one leg of the triangle, we know the angle, 80 degrees. So we'll be able to find A. Okay, let's set up tangent of 80 degrees. By definition is opposite 3.5 over adjacent, which is A. From where? We just simply swap A and tangent 80. So we get 3.5 over tangent 80. If you want, you can calculate. And finally, we need to find B, because that's for tangent Y. So B is actually the whole 25 lengths. Then we subtract the small a. And we also subtract 20. Why 20? Because that part, this part, is actually 20 meters. Because we put two perpendicular, so that means we arrange a rectangle. So that's why 20 side is right there as well. So that's why we also subtract 20. Okay? So first of all, let's calculate 3.5 over tangent 80 is A. So use a calculator. Guys, don't forget to switch into degree mode so that you'll have right answers. So tangent of 80 degrees. So what I've got that A, so side A is going to be 0.617 centimeters. Oh, in this case meters. All right, so meters, sorry. So almost half a meter. All right, so then we can calculate B by plugging A right there. And we've got 5 minus A, which is 0.617. So we subtract, and we'll get 4.38 meters. Okay, that's B. We calculated, so now we have B as 4.38 meters. And then we can calculate tangent Y, or simply take Y as 10 minus 1, so inverse trig function of B over H. So we've got B as 4.38 meters over H, which is 3.5. And now we've got angle Y to be. So let's calculate that. So tan inverse of the fractions, 4.38 over 3.5. So what I've got around 51 degrees. So 51 and 37. All right, so from where I can figure out that the complete angle X, just remember, we already expressed that. So it's right there. So this is angle X. So we get, for angle X, simply Y 51.37 plus 90. So on top of that, we need to add 90, and it's going to be 141.37. So that's the final answer for the angle X. So as you can see, so it takes actually many steps. And this is definitely higher math or IGCSE extended. So that's a tricky question, and that's why I decided to highlight and reveal all nuance, all details. So as you can see here, we use a lot of tangent ratios, basically trig ratios, but it's also about how well you can recognize different patterns and standard shapes within a bit more complicated pattern. All right, hope you like that. And in the next video, we have a look at the problem 2, which is quite tricky as well. Peace out.